What's up guys, Onmaths here, and today we're looking at compound measures, which is basically speed, density, pressure, those kind of questions. We're going to be looking at a couple of speed questions and then we'll delve into a density question. So the most important thing we know for these is the formulas, and most people recognize these formulas in the form of a triangle, and so this is all about speed. So we do our speed, distance and time triangle. And the thing about this triangle is you cover up the one that you're looking for. So I'm looking for speed, so I cover that up and it says it's distance divided by time. And there's a small spanner in the works here because it wants the speed, if I move that back, it wants the speed in miles per hour, but the question gives us miles, which is good, and minutes. So we first of all need to convert those minutes into hours. So to convert between minutes and hours, we divide by 60 because there's 60 minutes in an hour. Now be careful with that because some students think that there's 100 minutes in an hour when they do calculations like this. Now you'll get a horrible decimal on the calculator, which is fine. And we're just going to write it down like that. And it's 0.083 recurring, with the 3 being recurring. Okay, now we use the formula. So it says speed equals distance, which it says is 3.5, over time, which in hours, we should write the units here, it's 0.083 blah blah blah. So on the calculator, I'm going to keep that answer in the calculator, the 5 divided by 6 answer, and all you need to do is press the fraction button, put 3.5 on the top, and at the bottom just click the answer button, and it will restore that answer in the calculator, and that gives me the answer of 42. Now I could have written 3.5 over or divided by 0.08 and then just keep typing 3 for a little bit. But you might get an answer that's different to 42. You might get it's like 41.99999, something like that. So just round it to 42 as your answer. OCR have a similar question for us, but there's a few more things going on here. So we have kind of two journeys. We've got a journey of the bee going to the flower. So we've got what's it, the hive here, and is it a flower? I think it is. Yeah, so flower here, and we're told that it's traveling 7.5 meters per second for 10 seconds. Okay, then we're given a return journey. I should put the arrows on these really. So that's going to the flower and that's going back to the hive. And it says it takes 15 seconds to go back to the hive. Okay, so what we don't have here is the distance. So we've got the speed and we've got the time, but we need the distance. So we remember our speed, distance, time diagram. We've got speed at the bottom, distance at the top, and we've got time at the bottom as well. So we're looking for the distance, so we're going to cover up the distance. That's what we're looking for. And it says that what we do is speed times time. So distance equals the speed, which it says is 7.5, times the time, which it says is 10. So that would be 75 meters. So we know that on the return journey as well, it'll also be 75 meters. So we've got the time and we've got the distance, which is 75 meters. Okay, so to work out average, or the average speed, we need total distance over total time. So average speed, and we just use our triangle at the side there, which just says distance over time, but it's going to be total distance over total time. So the total distance is the 75 on the way out and the 75 meters on the way back. So 75 times 2, which is 150. The total time is the 10 seconds on the way there and the 15 seconds on the way back. So just add those together, that's 25. And then do 150 divided by 25, which is 6. So it'd be 6 meters per second. Now, it says in question B, if the bee is not assumed to fly in a straight line. So we've had the bee fly in a straight line there because it says assume the bee always flies in a straight line. But if the bee going from the hives to the flower or the return journey did more like this, like that, what's that going to do with the distance? What's that going to do to the distance? Well, it's definitely going to increase the distance. So in our answer, we definitely want to say this will increase the distance. We definitely want to mention that. And our answer is about the speed. Our answer is about the average speed, so we need to make a comment about that. So if the bee has travelled a larger distance in the same amount of time, that means that the average speed will have increased. So this will increase the distance and the average speed. And you can say something like, this will increase the distance, therefore this will increase the average speed. But as long as you say that the average speed may be greater if it's not flying in a straight line, the distance will definitely increase, because the quickest way between 2 points is always a straight line. So if you're not going in a straight line, then the distance will increase, and therefore so will the speed. Last up, we've got our Edexcel question, and this is not about speed, but it's about density. But density, speed, pressure, they all use the same triangles. Well, not the same triangles, but the concept of the triangle works for each of them. This time, though, the density is at the bottom, and the compound unit will always be at the bottom left, so speed or whatever, pressure. At the top for this is mass, and at the bottom is volume. Now, these triangles are just something you have to learn, and a lot of students will write these down just before the exam and just make sure that it's in their head, because you can't do this question without knowing about the formula, that density is mass over volume. Now, you can actually work out the formula, because if you look at the units of density, it says grams per centimetres cubed. Well, grams is a measurement of mass, and centimetres cubed is a measurement of volume. So it's telling you that it's grams on the top and volume at the bottom. So that's a little bit of a tip. Same with miles per hour. Miles is a unit of distance, that goes on the top. Hour is the unit of time, that goes at the bottom. Okay, so we've got apple juice, fruit syrup, and carbonated water. So let's start off with the apple, then we'll move on to the fruit, and then we'll do the carbonated water. And we're given two measures for this. We're given the density of each, and we're given the volume of each. So to work out the mass, which we need to work out for each of these, all we need to do is multiply the density by the volume. So the density of the apple is 1.05. The volume is given here, so it's 25 centimetres cubed. Yeah, that's right. And so the answer is 26.25. So let's keep going. The mass of the fruit syrup will be 1.4 times, and it says it here, 15 that we're using. So on the calculator, 1.4 times 15, it's going to be 21. And the carbonated water, you can work out the mass, which is 0.99, times it by the volume, which is 280. So 0.99 times 280, and that gives us 277.2. So we can work out the total mass now. So we'll have our total. So it's this string here. So the mass will just be adding all these up. So 26.25 plus 21 plus 277.2. and that gives us 324.45. Now the question asks us to work out the density of the drink, and so we need to work out the density, and we just use the triangle again. It says mass over volume. We've worked out the mass, and it tells us the volume. We could have worked it out by adding 25, 15, 280, but it's been nice to us, and it's just given us it. And let's just scroll this down a little bit. So divide that by 320, and we get 1.0139 blah blah blah. Now the question does say for us to do it to 2 decimal places. Always check the question to see whether it says that, because if it says it, you need to do it. So to 2 decimal places, line goes down there. 3 won't move that 1 up, so it's just going to be 1.01 as our answer. So that looks quite complicated, that question, but actually it was just doing the same thing 3 times and just knowing that density formula. If you knew the density formula, the rest of it just follows. But for 4 marks, it's definitely worth doing. Well, I hope you found this video useful. If you did, please click the like button. Also, keep your comments coming in. There's loads of suggestions of stuff to do after our summer school's finished. So really grateful for that, and just keep them coming in. If you want to see more from us, we release videos every single weekday, Monday to Friday at 9 o'clock in the morning. So just click subscribe, click the bell icon to make sure they go straight to your inbox. If you haven't already, which I'm sure you have, check out our website onmaths.com. It's full of free resources to help you with your maths. There'll be a card that magically appears at the top of the screen now to take you straight there. Otherwise, thank you very much, and I'll see you tomorrow.